Now we're going to do the same thing with numbers 46 and 47. We're going to answer them together and kind of back solve. So which choice provides the best evidence for the answer to the previous question, which is the author notes that one reason Higgs theory gained acceptance was at it. So we're looking for a question or like a little line section that tells us why it gained acceptance. So we're going to start with 36 to 39, push to mass. So we're going to go back to the passage, and we need to go back to the passage with every single one of these, and we need to make sure we're looking at every one of these answers, or we can end up in some hot water. So 36 to 39. That's going to say, starting with push, ending in mass. Push on a fundamental particle in an effort to increase its speed, and according to Higgs, you would feel its drag force as resistance. Okay, this doesn't tell us anything about why it gained acceptance. We're going to eliminate that one. 43 to 45. Its interaction to field. So, its interaction with the watery environment has the effect of endowing it with mass. So, with the particles submerged in the Higgs field. That doesn't tell us anything about why it gained acceptance. That just tells us a little more information about the actual concept of the Higgs field. So we're going to get rid of that one too. 55 to 63. But to environment. Let's see. But Higgs persevered and appeared later in another journal, and physicists who took the time to study the proposal actually realized that this was a stroke of genius, one that allowed them to have their cake and eat it too in Higgs' scheme. Blah, blah, blah. Particles mass relegated to the environment. Great. That tells us that they liked they liked Higgs theory because it allowed them to have their cake and eat it too. So that seems like a pretty good answer. We're going to keep it, and we're going to go to D and check that. 78 to 83. So that says, what are we starting with here? On occasion to them. So we're going to say, on occasion, that happens in physics. Mathematical equations can tell such a convincing tale. They seem to radiate reality so strongly that they become entrenched in the vernacular of working physics even before there's data to confirm them. That does not tell us anything about why it was accepted. So we're going to get rid of that one too. We're going to say C. They accepted it because, which is going to be our anticipation for this next answer, because it allowed them to have their cake and eat it too. What does that mean? It allowed them to basically keep their pristine equations because they don't have to deal with the particle's mass. So keep equations, no mass. Let's say that as an anticipation. Great. A. Let scientists accept two conditions that seemed previously irreconcilable. That seems pretty tempting, right? Because it says it allows them to keep their equations and not have to deal with the mass, which was a problem that they had before. Now we're going to go to B. Introduce an innovative approach that could be applied to additional problems. It doesn't say anything about additional problems here. We say, obviously, not even in our anticipation. C. Answered a question that earlier scientists had not even raised. That's completely irrelevant, doesn't have anything to do with anything in the passage. Explained why two distinct phenomena were being misinterpreted as one phenomena. This one could be tempting because it's talking about two phenomena and one phenomena, but it's not saying anything about misinterpretation. So we're going to get rid of it, and we're going to know that our answer here is A.